Howdy, team. Welcome to this series of videos about object-oriented principles and particularly abstract classes. For this video, we are going to review polymorphism. We are going to make a case for abstract classes when strict polymorphism isn't quite enough, and then we are going to test our knowledge with some extra exercises. So let's get started with that part one, where we review polymorphism. Okay, so I have created a little mock application for us to play with today. So what we're looking at right now is a class called rectangle. This is a rectangle that we could draw on a canvas. So you can see that the rectangle takes 5 parameters: x, y, width, height, and a color. And we can draw that rectangle given a graphics object. So we can set the color, and then we're going to draw the rectangle like so. There are some different properties about a rectangle that we might need at some point, like get parameter, get area. There's also getters and setters for all of the properties that we talked about above. So that's our rectangle class, and I said that it was intended to be drawn on a canvas. So let me show you the canvas class. In this class, you can see that we have an array list of rectangles here. So those are the ones that we're going to paint on the screen. We set up our canvas. It's going to be 400 by 400. We make sure that it can close, and then we add our canvas on it. And a canvas is this little private class that we have here, where the only thing that we're including on it is paint component. So we're just going to paint right on top of a JPanel. And all that happens in this method is that we're going to make the stroke a little bit wider. I wanted to make it wider so that you could see it on this video. And then we're going to go through each of the shapes and we're going to draw them. So that's all that happens when our panel is rendered. So when this set visible function is called, we're going to paint the component using this method. So the canvas component, which is the JPanel that's added to our JFrame, is going to get painted when it becomes visible. This is how it's going to be painted. And finally, in our main method, all we do is we create a new GUI. So let me show you what it does at this point. You can see here we're creating a new rectangle of, it starts at x of 100, y of 50, is 150 pixels wide and 200 pixels tall. That one's going to be red. There's another one that's going to be green. And you can see we end up with something that looks like that. Okay, so I'm going to close that. Now we are back here, and I have decided, as maybe let's say it's like a week from now, and we've decided we don't just want to create rectangles. Maybe we want to create squares as well. So we know through polymorphism, we're able to create a square that inherits from rectangle, has all of the properties of rectangle, but also has a couple of specific square things. So let's create a new class. So I'm going to go to File, New Class. It's going to be an abstract demo.shapes. That's correct. So that means I should call this one square. Modifier should be public. And my superclass is not object. My superclass, let's see if it allows me to do this. My superclass is, okay, abstract classes demo.rectangle. Okay, and then finish. Great. So what this has done is it's added an import statement, which is actually not really necessary because it's in the same package as we are. So now we have this square class. It's telling me that we need to have a constructor. So I'm going to allow it to create this for me. When we create the constructor, excuse me, you can see that what's created is it has added all of the parameters that are required for the rectangle constructor. Because in any child class, the first thing that is going to be called is the super constructor. So this is the constructor for rectangle, which needs to be executed before we do any configuration for square. And the only constructor that we have for rectangle has 5 parameters to it. And so there's no way we could create a square without having these parameters. But let's talk about what is different from a square than a rectangle. A square keeps track of a side length. It doesn't really keep track of an X or a width or a height. The X and the Y are going to be the same, but the width and the height, we actually really only have an int side length. Maybe we can call it that. So when we create our square, we create a side length. Let's add side length here. And we'll make that private. So private and side length. And then when we call the super constructor, we know that the width and height of the rectangle, if the rectangle is actually a square, we know that that width and height are both going to be side length. So I'm going to add side length here. We also know that we want to give it a special color, so that's fine. Then here, one extra thing that we need to do is we have one extra property here that we need to set, or a field. So we are going to say this dot side length equals side length. And that's all that we need to do for the constructor. Let's look at the rectangle class and see if there's anything that we need to fix. Let's see what the error has here. What's it unhappy with? I don't know. Okay, let's see if that maybe that goes away later. Let's look at rectangle. All right, so do we need to draw squares any differently? I don't think so. Even though the width and the height are going to be the same, I don't really think we need to draw them any differently. So then get perimeter, that's probably about the same too, because it's going to compute the same way for rectangles and squares. Same for area. Get X, set X, get Y, set Y, all of those should be the same. Get width should be the same. But if somebody calls set width, we need to make sure that it sets the height too. So here, I'm going to copy this function into our square because this is one that we want to override. And I'm going to add the override tag just to make it clear to the compiler what I'm trying to do. So here in the set width function, I am going to call super.setWidth. I can't remember if it's going to let me do that. That looks like it will, which is great. Okay, so what this is going to do is it's going to set the width the way it normally would, which is good. We want it to do that, but we also need it to set the height and we need it to set the side length. And I'm just realizing now that we don't have getters and setters for that. So I am going to create them I'm going to right click, go to source, generate getters and setters. And I want it for side length. It's going to do that. I'm going to add it at the end, generate. Okay. And that warning did go away, which was fantastic. Okay. So we were in the set width function, and we said that whenever someone calls set width, we also want to make sure that set height is called and that set side length is called, because we want to make sure that all three of those maintain the same size. So here I'm going to call set height, and I'm going to send in width. And I also want to call set side length with width. Now I could just say side length equals width. I could do that. I'm choosing to use the set function just for consistency because we've used set with all of the others. So you could do the other, that would be okay. I'm just making the choice for a reason. Okay, so we said that set width would need to be a little bit different for a square than for a rectangle. Let's keep looking. Okay, so get height would still be the same. Set height, we probably want to change. So I'm copying that and I'm moving it over, and I'm going to add an at override tag. Okay, so we have set height. Now I want to call, I'm going to do basically the same as I did in the set width function. I'm going to call super dot set height, and I'm going to give it the height 2 semicolons. Okay, so after set height, I am going to now set width, and I'm going to call, or it shouldn't be width, it should be height. If y'all were in class with me, you would have told me that was an error. And we want to set side width again, height. So just to recap, it's not side width, it's side length. Okay, to recap, what we did is we wanted to make sure that anytime we set the width of our square, which could also be called a rectangle. So whenever we set the width of a rectangle that's called a square, we want to make sure that all three of these things are set. And whenever we set the height of our square that could be called a rectangle, we want to make sure that all three of these are set. We probably also want to do that in our set side length function, because whenever this is changed, we want all three of them to be changed. So here, because this is set side length here, I want to add set height, and I want that to be side length, and I want set width with side length. So if any of these are called, then they're all going to set appropriately. However, if you see the way we have set this up now, so whenever we call set side length, we need to set the height and we need to set the width. We could get some sort of infinite recursion going on here, because set height calls set side length, which calls set height, which calls set side length, and it gets a little bit tricky. So let's simplify some things first. Whenever we call set width, let's just call set side length, because we know that set side length is going to be called here. We're going to do the same thing for height. Now we know that set height and set width are both going to happen this way. Let's see if inside this function, we're able to call our parents' version of this function. I'm not sure if it's going to let us, but let's see. I hope you appreciate that I am just programming this as I would program anything. I don't have a proper plan in mind. I think it's important that you see how software can just evolve based on, as you're writing it, you make decisions. Okay, so let's make a new square. So we're going to say square equals new square, and let's say the x is 35 and the y is 80, and we want it to be 200 pixels wide, and we want it to be color dot orange. This is going to be red, green, and orange, super stylish. Okay, so we have this square first. Let's add it to shapes. And hopefully what we're going to see is a new square on our window. Good, yeah, you can see the new orange square is there. Looks like we've created the shape appropriately. Also, notice that we were able to add a square to an array list of rectangles. So we're just calling the square a rectangle. And once it's added to shapes, we can no longer use any specific square stuff, but that's okay. All right, I want to test these get and set functions. If we set the, let's call set width. Maybe we want to change the width from 200 to 175. So I'm going to say square dot set width to 175. And let's see what that does. Awesome. Okay, so this was the one from before. And this is the one from now. You can see that the one from now is a little bit skinnier, so our get and set functions worked appropriately. Awesome. I close both of those. Great. We don't really need, well, we can just leave it because that was part of our progression. Okay, so now we have this square. Fantastic. What I showed you in this review of polymorphism is that we had a class called rectangle, and we decided that rectangles can be specialized just a little bit more. There's a specific type of rectangle that has slightly different properties, but it would be really useful if we were able to rely on what was already written in rectangle so that we have a much shorter class. We don't need to repeat ourselves in the square class by doing all of the things that are in rectangle that are relevant, like get perimeter is the same and get area is the same and draw is the same. So that is what we were able to do in this case by creating this new square class, where this class is much shorter than it otherwise would have been if it needed to duplicate everything that was in rectangle. We were able to use its constructor for the majority of our operations. We were able to use its getter and setter functions. Alternatively, we could have made those variables protected and thus available to us. I chose not to do that so we could explore what getters and setters mean in the polymorphic case. Then or inheritance case, I guess, not exactly polymorphic. Then I wanted to show you how getters work. We did all of that. So mostly squares to really simple class with some modified getters and setters. That's it, which was really useful. And our canvas can draw squares just the same way as they draw rectangles, because squares are rectangles. So notice we didn't need to modify our drawing function that just goes through each rectangle in the list of shapes and draws it. We added a square to it, and that was just fine. In the next video, we are going to make a case for abstract classes. What happens when we extend beyond the realm of rectangles and we want to draw circles and triangles? How do we do that? I will see you in the next video.